Here's one more example using the binary method, and after this I'm going to show you the quick method. If a PC had an address of 172.168.1.1/17 or 172.168.1.1, 255.255.128.0, you would once again need to work out where the subnet and host portions are split. In this example, /17 means that 17 bits of the 32-bit IP address are used for network or subnet, and the remaining 15 bits are used as the host portion of the address. So 172.168.1.1/17 means that the split takes place in the third octet. The reason why, once again, is the first octet is 8 bits in size, the second octet is 8 bits in size, so that gives us 16 bits. 17 bits in the network or subnet means that the split between subnet and host is in the third octet. So once again, you need to convert the third and fourth octet into binary. There's no need to convert the first two octets, as they are part of the network or subnet portion of the address. You only need to convert the host portion of the address into binary. So in binary, 1 followed by 6 binary zeros followed by 1 equals 129 in decimal. 7 zeros followed by binary 1 is the binary equivalent of 1 in decimal. Once again, refer to the binary section of this course if you're not sure how to convert decimal into binary and vice versa. So once again, 172.16.1 is the network or subnet portion of the address, and the remaining bits are the host portion of the address. So to work out the network or subnet portion of the address, you need to fill the host portion of the address with binary zeros. So this green portion of the address needs to be filled with zeros, and that would give us the subnet, which is 172.16.1. That binary 1 is part of the network address, followed by 7 zeros, followed by 8 zeros. So in the third octet we have 1 binary 1, followed by 7 binary zeros, which gives us the equivalent decimal value of 128. The fourth octet is filled with binary zeros, which will give us the equivalent decimal value of 0. So the subnet that this host 172.16.129.1 resides on is 172.16.128.0. To work out the first host in the same subnet, you need to fill the host portion with binary zeros except for the last bit, which is set to binary 1. And that would give you 172.16.128.1. To work out the last host, you fill the host portion of the address with binary 1s except for the last bit, which is set to binary 0. So that would give you 172.16.255.254. Now just to make sure that you understand this, notice the third octet is filled with binary 1s. There is a single red binary 1 followed by 7 green binary 1s. That, however, is a single octet, so there are 8 binary 1s, which gives you a value of 255. The fourth octet is filled with 7 binary 1s followed by a binary 0, which gives you a decimal equivalent of 254. To work out the broadcast address, fill the host portion of the address with binary 1s. So that would give you 172.16, 8 binary 1s in the third octet, which is 255, and 8 binary 1s in the fourth octet, which is 255. So the broadcast address is 172.16.255.255. So in summary, host 172.16.129.1 is on subnet 172.16.128.0. The first host in the subnet is 172.16.128.1. The last host in the subnet is 172.16.255.254. And the broadcast address is 172.16.255.255. I hope those 3 examples have helped you learn the binary method to work out the subnet, first host, last host, and broadcast address when presented with an IP address of a host and its subnet mask. Now that we've seen the binary method, let me show you the quick method, which allows you very quickly to work out the answers to questions like what subnet is this host on, what is the broadcast address, what is the first host and last host in the same subnet as this specific host. This method is reliant on you remembering tables and methods rather than relying on binary. So the first table to remember is the following. The values at the top of this table, like 128, 64 and so forth, are the decimal equivalents for the binary values, such as 1 followed by 7 binary zeros is equal to 128. 3 binary zeros followed by binary 1 followed by 4 binary zeros is equal to 16. You should be quite comfortable to write out this table from memory before attempting any subnetting question. So remember, it's 128, 64, 32, 16, 8, 4, 2, and 1. In the IP addressing section of this course, I explained those values in a lot of detail and explained how you get to those specific values. So I'm not going to cover it again here. To work out the values in the second line of this table, just take 256 less the top value, which will give you the second value. So 256 minus 128 gives you 128. 256 minus 64 gives you 192, and so forth and so on. As an example, 256 minus 32 gives you 224. 256 minus 1 gives you 255. So you only need to remember the top values, and then it's fairly simple to work out the values in the second line. A lot of people just memorize the entire table for speed and efficiency. But once again, write this table out before attempting any binary question. So if you were given a host address of 172.16.35.123/20, or the decimal equivalent 255.255.240.0, the first thing you need to work out is, where's the subnet mask not equal to 255? And secondly, make a note of that octet. In other words, that the network and host portion both reside within that octet, where the subnet mask is not equal to 255. So in this example, once again, we have an address 172.16.35.123, and the subnet mask is 255.255.240.0. So in the third octet, the subnet mask is not equal to 255, but is equal to a value of 240. That means that in this octet, there's a split between the subnet and host portions. So the first two octets are network or subnet. The last octet is host. But in the third octet, there's a split between subnet and host. Step 2 is to subtract that subnet mask value that is not 255 from 256. So 256 less 240 would give you 16. What 16 tells us is that networks are incrementing in values of 16. So the first network would be 0, second one 16, third one 32, fourth one 48, and so forth and so on. The 16 lets us know the increment of the networks. Now the table I showed you in step 1 will allow you very quickly and easily to work this out. So in the third octet we have a value of 240, so 256 less 240 gives you 16. So remember, in the third octet the subnet mask was 240, 256 less 240 gives us 16. Notice in the IP address the third octet value is 35. So part of 35 is network and part of 35 is host. So in step 3 we work out where 35 fits in the range of networks worked out in step 2. Now in step 2 we worked out that 256 less 240 is 16. So our networks are in multiples of 16. So just start at 0 and go until you are past the value in the question. So as an example, the first network would be 0 in the third octet, the second network would be 16 in the third octet, the third one would be 32, and the fourth one would be 48. So 35 sits somewhere between 32 and 48, and thus we know that 172.16.35.123 is on network 172.16.32.0. The way you work that out is to leave the network portion of the address the same. In other words, this blue portion, the first two octets, remains the same. The subnet or host octet that lies between 32 and 48, as per our calculation in step 3, gets rounded down to the nearest value. So 35 is between 32 and 48, and rounding 35 down, we get 32. So the third octet is equivalent to 32. Lastly, the host portion of the address is just set to 0. So you now know that 172.16.35.123 is on network 172.16 because the blue portion or network portion remains the same. 35 is rounded down to 32 because the subnet host portion lies between 32 and 48, and the host portion is just set to 0. In other words, 172.16.32.0. It's as simple as that to work out the subnet that a host resides on.